right, so just get pulled up, but I'm going to go ahead and start explaining. All right, so with the exponential functions here, the form for these are specifically going to be the basic form, which is y equals a b to the x power. Now, we talked yesterday about what these different letters mean. What did I say the a value represents from yesterday? So think back to the exponential family paper that we did yesterday. It's your starting value, or if we're looking at a graph, it's your y-intercept. So it's either the starting value if you're talking about a scenario, it's a y-intercept if you're talking about a graph. All right? Your b value is your what? It's the base, and the other name for it is the common ratio. Essentially, it's the number that you're multiplying to get from one y value to the next. All right? So when you're looking at a table, you first want to check that your x values are going up by 1. If they are, the next part is really easy. All right? Now, does anyone notice a pattern in the y values? How did they get from 2 to 6, 6 to 18, 18 to 54? Not giving you a hint. You're going to be multiplying something. Maddie?
By 3.
It's by 3. So here, we're multiplying each by 3. The great thing about this is that since we're multiplying by 3, it's a geometric sequence, this is our common ratio, otherwise known as our b value. So 3 is our b value. So that means for this function, we'd have y equals something, 3 raised to the x power. Now we just have to figure out what goes here. So we actually do have our y-intercept listed in this table. What is it? 2. How do you know that? Right. So right here, the x is 0. So the y-intercept has to be 2. Because remember, the y-intercept written as a point is 0, and then whatever number on the y-axis it is. So you plug that in. So 2 is our a value. So we put 2 here. And this would be our function. So if I typed it in, I would have y equals 2 times 3 raised to the x power. And I froze it, so you can't see it. Lovely. There you go. So if you hit submit, it should be correct. So essentially with going from tables, as long as the x's are going up by 1, figure out what number they're multiplying to get from one y value to the next. That's your b value. Then look for where x is 0. That's your a value. All right, that corresponding y value is your a value. If not, like if they don't have x equals 0 on the table, you may have to work backwards or forwards to get to it. So just keep repeating the pattern. Go backwards. Does that make sense? All right, so make sure that is inputted in your Delta Math so that you get credit for it. All right, that should be your correct answer. Yes. Yeah, quickly. So again, jot that down. You may need that. All right, can I erase? All right. All right, now we're going to do the one that says exponential functions basic. And it's the first one listed there, so I don't know if it says single on your end, but if it doesn't, it's the first one that says exponential functions basic. So the problem should look like this. Now, you are going to want a calculator for this, so if you don't have one, grab one. decay problems. So just to review from yesterday, the equation for exponential growth, or the formula for exponential growth, is y equals a times 1 plus r raised to the t power. Decay is y equals a times 1 minus r raised to the t power. So basically, they're the exact same formula, except one has a plus, one has a minus. That's the only difference. Now, remember, your a is always your starting value. Your r is your rate of increase or decrease. And your t is the amount of time. So, let's set up the equation first. So, $7,800 is placed into an account with an annual interest of 6.5%. How much will be in the account after 29 years? And it says to round to the nearest cent. So first off, we need to decide, is this going to be a growth or decay problem? Growth, how do you know?
Because this is annual interest.
Interest. So guys, when you think bank account, all right, if it gains interest, that means it's growing in value. So this is a growth problem. All right. So what's my A value here? Right, it'll be 7,800. So that's my A value or my starting value. What's my R value? 6.5% R. And remember, you always have to convert that percentage to a what? Decimal. So what would it be as a decimal? Right, so it'd be 0.065. If you didn't know that, just do 6.5 divided by 100. So that's our R value. And then what's our T? So remember, T means time.
29 years.
29 years. So this is T. So now we got everything we need. So we're going to put this into our growth formula. So I will have y equals A, or 7,800, times 1 plus 0.065, all raised to the power of 29. And then guess what? To get our answer, we just put that straight into the calculator and round it. So go ahead, put this exactly as you see it into the calculator and tell me what you get. What do you get?
48,443.245.
So 43,000. What?
48,000.
48,000. Say that one more time.
443.
443. Round to the nearest cent, so 2 decimal places. 0.25 dollars. So this right here would be our answer. So remember, if they tell you to round it to the nearest cent, if we're thinking money, that's 2 decimal places. All right. So if we input this, it should be 43.25 should be the correct answer. So again, the basic ones are fairly straightforward because all you gotta do is figure out if you're using growth or decay, set it up, put it in your calculator to get an answer. Very straightforward. Any questions on this one?
Can you scroll down so I can see how you type it?
Oh yeah. It's right here. So don't put commas. Just type it straight. Delta math's weird about commas for whatever reason. Mathematically, that's how you write it, but
I'm like, what am I doing wrong?
it doesn't like Delta math just doesn't like commas for some reason. Even though that's how you write numbers like that or whatever. All right, are we good on this one? Can I erase? All right, so we're gonna do the last single problem together. Which is exponential from 2 points. It should be the very first one listed. So exponential from 2 points. And it should be this problem. Now, this looks difficult, but it's actually not too bad. So, the way I told my freshmen to do this is turn your points into a table. That's how you want to start. So, I'm going to turn these 2 points into a table, x, y. So, for the first point, 0, 13, I'm just going to have 0 as my x, 13 as my y. Now, leave a lot of space, and you'll see why in a second. But my next point is then 8 and 33, 28. So, the way we figured this out is that we're trying to figure out what we need. So, first off, we already got our A value. What is it? So, we're using this form. So, y equals A to the b to the x power. We already have A. What's A? 13. So, we already have A equals 13. So, the hardest part here is figuring out what B is. All right? The easiest way to do this is figure out what you need to add to get from 0 to 8. So what do I need to add to get from 0 to 8? 8. Just do plus 8. That's how many steps we do. Now, I then want you to figure out what number we need to multiply to get from 13 to 33, 28. So in your calculator, if you wanted to figure that out, how would you do it? Right, just do 33, 28. Right, divided by 13, and that would be 256. Now, our base is the number that will get us from one step to the next. So our base would be from 13 to whatever value we get for x equals 1. And then whatever value we get, and then whatever value we get for x equals 2. We are currently experiencing technical difficulties. Give me a second. There we go. All right. And so on and so forth until we get to 8. Now, we said that it takes 8 steps to get from 0 to 8. So guess how many steps they'll get from 13 to 33, 28? How many steps do you think? 8. Took 8 steps to get from 0 to 8, so it should take the same amount. So that means that we have 1, 2, 3, 4, 5, 6, 7, 8 steps to get from 13 to 33, 28. And for each of those steps, we're multiplying the exact same number. So in reality, that number multiplied 8 times would give us 256. So in other words, we're looking for a number raised to the 8th power that equals 256. So let's call this number B because we're trying to find the B value. Let me ask you this. How do you undo a exponent? Not necessarily a square root, but we do take a root. So square root undoes a square. A cube root undoes a cube. What do you think undoes an eighth? An eighth root. All right. So literally, you would take the eighth root of both sides. Now, you can do that in your calculator. All right. So the way you do it is as soon as it pulls up. All right. So the way you do it is you will first hit the number 8. That represents what type of root this is. So click 8 first. Then you will hit the math key, which is right below that green alpha key. Click that. Now you should get a list like this. Do you see how at number 5 it has like an X and then some radical symbol? That's the symbol that you use to create whatever type of root that you want. So you're going to click number 5 to get to that number. And now you got an eighth root. Now all you got to do is just type 256 up under it. So 2, 5, 6, hit enter. We get 2. So that means that to get from one step to the next, we're multiplying 2 8 times to get to from 13 to 330, 28. 3328. So our B value is going to be 2. So if we put that into the form that we want, we would get y equals our A value, which is 13, times our B value, which is 2, raised to the x power. All right. And that's what you type in. So again, we're going between 2 points. It's really easy to see if you have it as a table. All right. Like that's kind of how I taught it to my freshmen. Like it's really easy to see if you have a table. So figure out how many steps it takes to get from the 2 x's. You'll use the same amount of steps to get between the 2 y's. Figure out what you multiplied from the first y to get to the second. And then however many steps you took, that's the type of root that you will do of that product. Does that make sense? Kind of, sort of, maybe. All right. So if you plug it in, so y equals, you do have to type y equals in here, 13 times 2 raised to the x. You should get it correct. All right, any questions on any of these? All right, so the rest of this delta math is for you to do on your own, but not right now. All right, so that delta math won't be due until Monday. All right, so you have some time to get it done, but you should know how to do all the different parts of it now. All right, and remember, this is just review. We're not even in the hard stuff yet. All right, so if you have questions on this, you need to ask me because these are the basics that we're going to use for the rest of this unit.
Did you say people were doing some math?
Yeah. How do I know? I just taught it.
I was never.
Well, I literally just taught it to my math 1 kids last unit.
I think my
All right, can I erase this? All right, so the next thing that we're going to do is I'm going to have you guys work through a Desmos classroom activity. So you are going to log on to Desmos Classroom and you're going to click on the one called Match My Exponential. And I'll give you about 15-20 minutes to work through it. But it'll kind of lay the groundwork for what we're doing today, as well as what we did yesterday. All right, so good review. So go ahead and get that done. So again, go on to Desmos Classroom. Make sure it's student.desmos, or you can go in through Canvas, because I do have it linked in Canvas. And do the activity labeled Match My Exponential. It would already be assigned to you.